everyone. Welcome to the first talk in our 2021 methodology application series. We are the Nebraska Academy for Methodology, Analytics, and Psychometrics, and we are housed within the Nebraska Center for Research on Children, Youth, Families, and Schools. Today we have Dr. Kejin Lee talking to us about survival analysis, so measuring time to event type constructs. Dr. Lee is a research assistant professor in the MAP Academy. Just a heads up, we will have 4 more presentations this year. We have Dr. Jim Bovard, October 23rd, who will be talking about value-added effects and teacher and classroom type effects. We have Dr. Ray Reichenberg in February, and then 2 more presentations slotted for March and April. If you have any questions during Dr. Lee's talk, feel free to post a question to the chat box, and then we should have some time also at the end for a few questions. So other than that, I'll give it to Dr. Lee.
Hi, everyone. Thank you, Natalie, for the introduction. I'm Kejin Lee, a research assistant professor for MAP Academy at CYFS. So today I'll be talking about, I'm going to share my screen. So today I'll be introducing a brief introduction of survivor analysis. So I hope you find this helpful for your research. So this is an outline for today's presentation. So there are 2 parts. So for the first part, I'll introduce what is survivor analysis, the characteristics of the survivor data, and what kinds of research questions we can answer by survivor analysis, and what kinds of statistical method we can use to analyze survivor data. For the second part, I'll demonstrate data analysis using R. So for this demonstration, I'll use survivor function, survivor package, and survive minor packaging. So on the chat box, I'm going to share a couple of links where you can download our syntax for the second part, and also a couple of links where you can download our CU and R. So, oops. Okay, I'm going to just stop sharing this, and then I'm going to leave my okay, so I'll share links when we get to the R session, okay? Okay. So let me start with briefly introducing survivor analysis. So survivor analysis is a collection of statistical methods for analyzing timing of an event occurs. So it's all about making inferences about event rate. So the outcome of interest in survivor analysis is time, how long does it take until an event occurs, and event, whether event happened or not happened. So let me give you an example here. So this study was published in Age Care Journal, and this study investigated what kinds of factors are related to the survivor time of children with HIV in Ethiopia. So a lot of times in survivor analysis, outcomes of interest are related to their negative experiences like disease incidence or mortality. Okay, so this is just an example study, and here the event of interest of this study is mortality of children with HIV, and the time of their interest is survivor time of children with HIV. So when you frame a research questions in survivor analysis, you need to think about what is an event of your interest and what is time that you are going to measure. So time can be on continuous scale or discrete scale. Per se, you can measure times in days, weeks, months, or years, or oftentimes ages from the beginning of the trial. And also time can be semesters or student grades when they drop out from the school. So time is typically referred as survivor time, and it's denoted as a capital letter T. Okay, and events can be any kinds of experiences other than disease instance or mortality. So first, say you are interested in about the time until getting a job, or if you're interested in about time until getting a master's or doctoral degree, or if you're interested in like how long does it take until getting our peer reviewers' comments, and how long does it take until hearing from a collaborator or grant decisions. Also, this can be any kind of experiences such as disease instance in biomedical science as well. So because events can be any kinds of experiences, so that's why survivor analysis technique could be applied in a variety of research topics in different disciplines. So events is typically denoted as delta, and it's indicated by a binary variable indicating whether event happened or it's not happened. Okay, so there is a difference between calendar time and survivor time. So for say we have 3 patients with breast cancer. So if you look at the first participant, this participant got into our study in year 2010, and an event occurred to this participant in year 2013. So this first participant's survivor time is 2 years. Okay, and you will notice that every participant is starting from the same time origin in survivor time, and there's no negative values in survivor time. So survivor time is always positive. And so if you look at the third patient, so this patient got into this study in 2010, and we don't know whether event happened or not happened to these participants because we couldn't observe it until by the end of the study. So if that's the case, this is called censored observation. So when you say censored observation, that is meaning we don't know the true survivor time because we couldn't observe an event happen to a patient. So that's the most important characteristics of the survivor data, and that is the reason why we can't use a regular regression analysis for survivor data. So you will see that the third participant was in our study for 4 years, but we couldn't observe an event happened. But at least we know that this person was in our study and was alive on like 4 years. But we don't know what is the true survivor time. So here are some key terms for survivor analysis. Like I said, survivor time is indicated by the capital letter T, and whether event happened or not happened is indicated by a binary indicator variable delta. So when delta equals 1, that means we observed an event occurred. So when delta equals 0, that means the observation is censored. So we couldn't observe an event happen. And you will notice there is a small letter T. So that is a specific time point during the study period. So here's how you can set up your data set for the survivor analysis. So first thing you need is a participant ID. And then you need to keep survivor time. And also you need a binary indicator indicating whether event happened or not. You couldn't observe an event happened. So these are the censored observations. And then you can add additional variables such as grouping variable, gender, and so on. So let's talk about censoring. So censoring is the most important characteristics of survivor data. And you can think about censoring like missing data. So censoring is when you say, per se, we have participants dropped out from this study before the end of the study. And then we couldn't observe an event occur to these participants. And another case of censoring is where we couldn't observe an event happen to our participants by the end of the study. So it's all about like we don't have true survivor time for participants. And right censoring is the most common type of censored observations. So it's the case where study ends without an event and participants were dropped out from the study. Okay, and for this presentation, I'll only consider right censoring. So there are different types of censoring. So left censoring is where true survivor time is less than or equal to the observed survivor time. And this happens when an event occurred before the beginning of the study. And interval censoring is where true survivor time is within a known time interval. So we know that an event happened sometime between T1 and T2, but we don't know what is the exact point where this event happened. So those are left censoring and interval censoring, but these are not going to be covered and they are not going to be considered in this presentation. So there are some assumptions about censoring, and the most important assumption of censoring is that survivor time is not related to the censored observations. So that means survivor time is not related to whether event happened or not happened. So that is non-informative censoring assumption. And how do we handle censored data? So censored observations have some information about time. So we should keep all the censored observations in our data set. So that way we can use all timing information available from our data set. Okay, and now I want to introduce what kinds of research questions could be addressed by survivor analysis. So these are objectives of survivor analysis. Let me give you an example. So first, say I'm interested in about survivor probability of patients with breast cancer. And if that's the case, I need to estimate survivor function. And Kaplan-Meier method is the most common approach to estimate survivor function. For say I'm interested in about comparing survival probability between two different groups, then I would go for log rank test. And that is the most common approach to compare survival probabilities between two groups. Now for say I'm interested in about different factors related to the survivor time. And I would go for Cox proportional hazard model. Okay, so these methods are the most commonly used ones in survivor analysis. And I'll cover Kaplan-Meier method and this test for comparing survivor probability difference between groups. So before jumping into statistical methods, I wanted to introduce key functions for survivor analysis. So like any other continuous random variable, survivor time has probability density. So that is indicated by Ft, like here. And when you interpret this, you can say the probability of an event occurs per unit time. So for say you're interested about the probability density at day 5, then you can say, you can interpret this as what's the probability of an event occurs at day 5. So next one is survivor probability. So it's typically denoted as a capital letter ST, and you can interpret this as the probability of observing an event given time point t. So let me give you an example here. So say we are interested in about the survivor probability at day 5, then you can interpret this as the probability of an event the probability of a patient with breast cancer live longer than day 2. So it's the probability of the survivor time is greater than two days. So if you look at the right-hand side, this is the shape of the survivor function. And if you look at the time point 0, it is equal to the probability of the survivor the probability of the, so this, if you look at the time point 0, that is the equals to 1, because no one has experienced an event at the beginning of this study. So next one is hazard function. So it's typically denoted as HT, and you can interpret this as, you can see that there is a condition. So this is conditional probability. And you can interpret this as, it's the probability of an event occurs given that the event did not occur by the time point t. And you will notice this is very similar to the probability density function, except for this condition part. So here are some examples. So you are interested in about hazard function at day 5. And when you interpret this, it's the probability of an event occurred at day 5, given that event was not occurred until day 5. And what about the probability density? It's the probability of an event occurs at day 5. So hazard function is conditional event rate, whereas the probability density function is unconditional event rate. So to give you some better understanding, here is another example. So let's say we have 100 people with breast cancer. And on the first day of our study, 50 people were dead. And the second day of the study, 20 people were dead. And in this case, what is the probability density, survivor probability, and hazard function on second day? So let's look at the survivor probability first. So I'll talk more about how to estimate this part in a few minutes. So the probability of an individual with breast cancer live longer than 2 days is 0.3. And you can see that this is the probability density at day 2, and it's 20 over 100. That is because there were 20 people who were dead on the second day, and there were 100 people who were at risk at the beginning of this study. So it's 0.2. You can think about this as the probability of an individual experiencing an event on day 2. So now let's look at the hazard function. It's 20 over 50. So there were 20 people who were dead on second day, and there were 50 people who are alive until day 2. So you will notice that the only difference between the probability density and hazard function is the denominator part because of the condition we have in hazard function. So point 4 is the probability of an individual experiencing an event given that this individual hasn't experienced an event until day 2. So that's the difference. Okay, so the last function related to the survivor time is called cumulative hazard function. And this is basically a accumulation of the hazard function. So it takes integral from 0 to integral of the hazard function from 0 to time point t. And one thing I want you to know is there is a exponential relation between survivor function and a cumulative hazard function. So you will see this relation, and this relation is used to interpret and estimate the parameters from Cox proportional hazard model. So you can just think about there's some exponential relation between these two functions, and these are used to estimate parameters for Cox proportional hazard model. So let's move on to the data analysis. So now I'm going to introduce how to estimate survivor probabilities by hand. So in reality, statistical software will do everything for you, but I just want to give you some more idea what's happening underlying statistical software. So that way you can have a better sense of interpreting our output or the outputs from the statistical software. So to calculate the survivor probability by hand, we need to rearrange our data set like this. So first thing we need to do is rearrange our data set by the ascending order of time. So the smallest values goes upper. And then we need to count how many people experienced events, and then how many censored observations we have by time, how many people are at risk by time. So this is a little different from what I showed you because this data set layout is for the computer program, and this is for the hand calculation. Okay. So the first type of research question is about interpreting survivor probability from a survivor data. And to estimate survivor probability, the Kaplan-Meier method is most commonly used. So this is what Kaplan-Meier method is. And you will notice that this is the product of the survivor probability by given a time point. So let me give you an example to help you understand this. So let's say we have 21 patients with breast cancer at the beginning of our study. So the survival probability at time point 0 is 1 because no one has experienced an event yet. So what about day 6? So the survivor probability at day 6 is calculated in this way. So we have 21 people who are at risk. So this goes to the denominator. And we have 3 people who are dead on the day 6. So we are going to use 21 minus 3 as our numerator. And then multiply this by the previous survivor probability. So it's 18 over 21. So the 0.85 is the probability of a patient with breast cancer live longer than day 6. So let's look at the survival probability at day 7. So there are 17 people who are alive, who are at risk. So it goes to the denominator. And there was a person who was dead on day 7. So 16 over 17 is multiplied by the previous survival probabilities. So the 0.80 is the probability of a patient with breast cancer live longer than day 7. Okay. In reality, statistical software will do everything. So you will see this output like here, and we're going to talk about this in a few minutes. And also you can have probability, survival probability plus like this, and you can locate where is the median survivor time in this graph. So median survivor time is oftentimes used to describe your survivor probability. And oftentimes you can compare the median survivor time between two groups in descriptively way. So let's move on to the log rank test. So this test is used to compare the survivor probabilities between two different groups. So you can think about this as a chi-square test where we are comparing observed cell counts versus expected cell counts. Okay, first thing we need to do is set up a null hypothesis. So our null hypothesis here is there is no group difference in survival probability between the first group and the second group. And then because we are going to hand calculate this, data set is arranged like this way. So we have the number of people who experienced events per each group, and we have the number of people who are at risk per each group by time. And these formula are, this is how you calculate expected cell counts per group. Okay. Once you calculate expected cell counts per different group, then now you need to get a difference between observed cell counts and expected cell counts. And once you sum all the differences across time points, then we can pull it into this formula, and then we can get the log rank test statistic. And we assume that this test statistic is following a chi-square distribution with degrees of freedom of 1. And you can see that we can calculate the variance and the numerator with using these formulas. So here is an example. So once you calculate the expected cell counts in this way, and then you can calculate the difference between observed cells to expected cells, and then sum of the differences across time. This goes to this numerator, and then this is how you get the log rank test statistics. And we got 16.79, meaning that we are going to reject the null hypothesis, and we can conclude that there's a statistical significance. There is a statistically significant difference in survivor function between first group and the second group. Okay, this is how we get the output from R, and we will get the chi-square statistics, which is the same as the log rank test statistic, and we'll get a p-value associated with this chi-square statistics. And again, we can visualize the survival probability per different group, and we can get the number of people at risk per different group. Okay, so now let's move on to the R session. So I'm going to share a couple of links where you can download our syntax. So okay. Okay, I am going to share Okay, let me share my screen again. So once you install your R and R Studio, this is R Studio, and it has four different places. So this part is where you save your R script, and this part is where you can get the results from your R comments. This is where you can execute your R syntax. And this place is where you can see your saved data set and where you can see your stored R objects. In this part, you will see plots or graphs. So when you hit the Control Enter, this way you will execute this R comment. And if you hit this comment Enter, if you hit Control and Enter, then you're gonna execute your R code. Okay, now I'm going to share a slide. Okay, so first thing you need to do is install these packages. We are gonna use Survivor package and plermeyer. So this package is, so you can use this command here, install packages, and then you can attach these packages using this library function. And then we can attach the example dataset cancer by using this data function. So the cancer example data is a built-in dataset in Survivor package. So in case if we want to use an Excel data that is not in our package, then we can use this package and then use this function and specify the location of your Excel file as the first argument. And then you can use this second argument to specify which page you want to use in your Excel file. So because we have a data attached in the Survivor package, we can just use the data function. So whenever I start the data cleaning, I always go for head function to see how my data looks like. So here we can see we have a time variable indicating Survivor time, and we have a status variable indicating whether event happened or not happened. And we have like gender variable. It's a grouping variable. This is just a recap for Survivor function and how we estimate Kaplan-Meier to get the survival probability. Okay, now let's use a serve fit function from Survivor package to estimate survival probabilities. So this serve fit function takes two arguments. So the first argument is for specifying your formula. And then the second argument is to specify the data set you're gonna use. And if you see this first argument, there is serve function. So this is where we can create a survivor object for a response variable. So remember that we, in survivor analysis, response variable is created by time and whether event happened or not happened. So we are gonna create a survivor subject for a response variable using these two arguments. So time equals time. So this is the variable name in our data set. And event equals status, because status is the variable that is in our data set. And then we can save this we can store the survival probabilities using this KM object. And then we can pull out the output using summary function in KMF object. Then you can see that we have the survival probability by each time. And we can also visualize the survival probability by creating a graph. We're gonna use this function from the plermeyer package. So the first argument is to specify the survival probability. So we already stored our survival probability in KM. So we have KM as the first argument. And then the rest of the arguments are actually optional. So we don't really need to specify this. But if we want to customize our graph, we can use these optional arguments. And this is the best part of the R because you can customize your graph or plots as much as you want. So the first argument is to set whether you want to set the confidence interval around this probability. So I set it as false, so it doesn't show up in this graph. And the next argument is to say whether you want to have your risk, whether you want to have this table in your graph. So I set it as true, so I have the table showing how many people we have at risk per different time. And we can we can actually locate the median survivor time in our graph using this argument. So it shows on your graph. So this is the median survivor time. And then this is where you specify the style of your graph. And so that's totally optional. And the last argument is to adjust the size of the table you want to have in your graph. Okay, so now we want to compare survival probability between two groups. And this way, in this case, we can use this serve_diff function, and it takes two arguments. So the first argument is where you specify formula, and the second argument is where you specify the data set. So if you look at the first argument, there is a gender variable because you want to compare survival probability between gender. And then if you look at this down here, so this is your R output from this function. And we'll get the chi-square test statistic. You can think about this as a log rank test statistic. So we have 10.3, and there is a p-value for that statistic. Okay, we conclude that we're gonna reject the null hypothesis, and we can conclude that there is a statistically significant group difference. So if we want to create graphs per different group, we can calculate the survival probability first using this function again. So now we have gender variable in the first argument. So this function takes two arguments, and we have gender variable right here because we're gonna create survival probability per different group. So we are stored the survival probability using this object. And then now you can see that we have survival probability per gender here and then here. Okay, also we can create graphs, create a plot for different groups using this function again. So the first argument is where we calculated the survival probability for different groups. And then the only thing that's different from the previous one is we added a legend title argument here. So we can have a legend title as gender in our graph. And we can also add legend labels arguments where we can specify the labels of the legend. So this way we can see that we have male, female labels here. So you can actually customize your plots or graphs using optional arguments in a function. So I think that's the best part of the R. And then we got this graph. This is the survival probability graph for different group. And we can also locate the median survivor time here. So we can compare median survivor time between two groups. And also we can have the people at risk per different group. Okay, so this is what I have today, and we went through the R session. So, okay, if you have any questions, let me know, and thank you so much for your patience, and thank you so much for your time today. Oops.
Okay, Jen, did you see the question from Jennifer?
Oh, actually, I'm having, okay, let me go back to, yep.
And I can read it to you if you can't see it.
All right, so let me stop sharing this. Yes, I can see the chat box.
Okay.
Okay. So, oh, actually, actually, Jennifer, can you explain your question again? Oh, so.
Hi, can you hear me?
Yeah, I can hear you well.
Okay, great. So my question was, I've seen this applied for things that aren't definitely going to happen. And so something like participating or responding. And so when you were talking about censoring, it made me question whether it was appropriate to use these types of models, because it seems like it's assumed that the event will eventually happen with enough.
Oh, no, actually, we are not assuming event will eventually happen or not. We just don't have the information because we couldn't observe an event happens. So you can, yeah. Does that answer your question?
Yeah, so basically the censoring does encompass kind of two things, that it hasn't happened yet, or it may never happen, and that's okay.
Yeah, that's okay, yes.
Okay.
We're saying that we don't have information about event happened. And other than that, we are saying it's censored.
But in the one of your examples, you had the ability to project, 100% of the event happening.
Mm-hmm.
So the model will project that, assuming that everyone will eventually have that event happen. It just might be wrong for some people.
Yeah. So I can go back to the PowerPoint and then. So you can see that, so we can see that in this graph, we have like, we are starting from 1, but it doesn't approach to the 0, right? So
Right.
eventually, like, we don't have to have everyone to have events, like, so that's why we have the probability never approaching 0.
Could you go to number 17? Maybe that's the slide I'm thinking of. Yes. So there's oh, that's a number. That's 1,000, not 100%. Okay.
Yeah, right.
Okay.
Okay.
Thank you.
So Kejin, maybe like Jennifer's question kind of makes me think of, the difference between like hurdle models and, like where you have the first question is, maybe this is a bad example. But yeah, it seems like certain events, what she's saying here is that death will for sure happen eventually to everyone. But other things, they may happen on average, but not for everyone. So that's okay here.
Okay. So yeah, I think that's okay. Yeah.
So it would still predict. Is this at all related to truncation? I wonder. Yeah, I don't know.
Yes, I think we are assuming that everyone has the same probability. So I think we should assume that everyone has a certain probability of having an event. Yeah. So even though, so you mean that if events will never happen, can we still use this?
Yeah, for some people. Mm-hmm. So her example is that time to respond to a request. Mm-hmm. Some people just may never respond to a request, even if you follow them indefinitely.
Yeah, but we are saying that there are probability. So the assumption here is that everyone has the same probability of experiencing an event. So even though it's not gonna happen or not happen in theoretically, but in the statistical method, we are assuming everyone has the same probability of experiencing an event. Does that answer?
Yeah, is there a way to relax that assumption?
Yeah, probably there is, but I'm not really sure at the moment. Yeah.
And then it looks like there's another question from Matt.
Yep. Oh. Oh. So the non-informative assumption is saying that the survivor time is not related to whether events happens or not happens. So first say, so you mean, it's a difficult assumption to make in practice? Matt?
Yeah, that's kind of what I'm getting at is, at least in a couple of the examples, it seemed like it'd be tough to make that assumption without potentially biasing the results.
Yeah, right. So yeah, in practice, a lot of times survivor time is related to an event's occurrence, but the reason why we're making these assumptions is to make our statistical analysis more decently. So that's assumed to make we make unbiased result from the plermeyer and other statistical method.
Thank you.
So what are the consequences if that assumption is not met?
Then we need to, you mean, if that's the case, if we're assuming that censoring is related to the survivor time, then I guess we need to account for those relations in our model. So we'll get an unbiased result from the plermeyer that we just talked about and other statistical method we're gonna use.
Okay, but there exists more flexible approaches that can account for violations of that assumption.
Yeah, I think survivor analysis is it is like a bunch of a wide variety of statistical methods. So I believe that there is some statistical method we can count into these relations. Yeah.
I had a question on slide 21, and I might ask you to pull that back up if possible.
Yeah.
So I was kind of trying to formulate like the math part of this, and I noticed that, so you multiply by 1 in the second row. In the third row, should you be multiplying by 0.8571 or by 1?
Oh. So you mean
The probability of survival.
Yeah.
Since it changes.
So we are gonna calculate this part from the data from available on day 6, and then multiply this by the previous survival probability, which is this one.
So on the third row, are you multiplying by 1 still or by 0.85?
0.85.
Okay.
Yeah.
Just making sure.
Yeah, sure.
Sorry, like the TF means the day, right?
Yeah.
And if I calculate for the 6th day, should I use the information from day 5?
Yeah, that's right. But we don't have people experience events on day 5. So we are assuming that we have, yeah.
So it's just because there's no event happened before day 5. Or before day 6, maybe.
So we can think about this way. So until day 6, we have 21 people who are there, and until day 6, we have people experience events. Like 3 people experience events by this day 6.
Okay, yeah, I can see, like if we list from 0 to 7 for the first 6 days, the NF will all be 21, right?
I'm sorry, could you repeat the question?
The number in risk set is 21 from day 0 to day 6.
Right, yeah, that's right. Yeah.
Okay, thank you.
We have another question. Is it routine to report median in the results? How do we usually interpret median in survival analysis?
Okay, so if we want to describe the survival probability, then we can use median survival probability. And yeah, it's a lot of cases studies report median survival probability. And we can interpret this as, so this is where we have like about like half of the people was survived, right? So like we are saying, we are interested about how much time, how long people live until they die because of their disease. And we want to know the survivor time of people, right? So we can say, in general, the people, like at least half of the people live 260 days, we can say that. So that's what median survivor time means. So does that answer your question?
And she said, yes, thank you. Thank you very much, Kejin.
Okay, yeah, thank you. Right.